Today we're going to learn how to use Pythagoras' theorem to find the sides of triangles. So, what is it that Pythagoras' theorem does exactly? And what is it? Well, you can see in the top right hand side here, I've written out Pythagoras' theorem. A squared plus b squared equals c squared. Now, what does it do? Well, it lets us find the length of an unknown side in a right-angled triangle. Now, let's apply that to an actual question and you'll see how it's done. So, here we have a right-angled triangle. Right-angled triangle with two sides that you know the length of and one side that you need to find out. This is perfect for Pythagoras. How do we get started? Well, the first step is always to label the sides. What do I mean by label the sides? Well, you see in our equation up here, we have a squared, b squared and c squared, and that means we need to find these letters a, b and c in the triangle. Okay, where do we start? Well, the longest side is the side opposite the right angle, and that longest side, the hypotenuse as it's called, is always labelled c. Now the other two sides can be a and b. It doesn't matter which one is which, as long as one of them is a and one of them is b. Now, let's apply Pythagoras. We know that a is 3 and b is 4, and c is what we want to find out. So let's have a look at our formula up here. A squared plus b squared equals c squared. If a is 3, then we have a squared, 3 squared, plus b squared, 4 squared, is equal to c squared. If you add 3 squared and 4 squared in your calculator, you get 25, because 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and this is c squared. Now, what are we looking for? Aren't we done? Not quite. We're looking for c on its own, not c squared. So how do we undo this square? Well, quite simply, we use our opposites rule, just like if you're rearranging an equation. The opposite of squaring is square rooting. So c on its own is equal to the square root of 25, which is just 5. So there we go. We found our longest side of our triangle using Pythagoras' theorem. Let's just recap those steps. Look at our triangle. Do we know two sides, and is it a right-angled triangle? If so, we use Pythagoras. Start by labelling the sides with the longest side as c, and either of the other two sides as a and b. Now we know which side is which. Put in the numbers into the equation, square root the answer, and you have your side. Now, let me give you an example to do. So, we have a right-angled triangle here, with sides of length 6 and 7, and you need to find the longest side here. So, if you pause the video and give this problem a try. Okay, I'm going to assume you gave that a try, so let's go through the answer. Where do we start? Well, exactly the same as before. We label the sides. Which side is which? We know that the longest side is c. And we know how it's the longest side because it's the side opposite the right angle. The other sides are a and b. Now we write out what is what. A equals 6, b equals 7, and c is what we want to find out. Okay, now we look at our formula. A squared, 6 squared, plus b squared, 7 squared, is equal to c squared. Put that into your calculator and you'll see that 6 squared plus 7 squared is equal to 85. Now, remember, and this is the step that everyone always forgets, 85 is c squared, but we just need c on its own. How do we undo that squaring? Well, we square root it. Now the square root of 85 is a big long decimal, and we're going to round that to 9.22. So c, this side here, is 9.22. Okay, that's pretty much all of Pythagoras, apart from one last bit. What if you know two of the sides, but instead of knowing the two shortest sides, you know the longest side, the c side, and one of the other sides? So, let's have a go at that. So you're given this triangle here, and you need to find now this bottom side here. How do we do that? Well, there's only one extra step, and that's making sure we rearrange the equation. But just like always, we have to start by labelling which side is which. So, the longest side is going to be C, the other sides are A and B. Now, we look at our equation up on the right, and we see that A squared equals B squared plus C squared. But what are we looking for? We're looking for B. How do we get B on its own? Well, we take away A squared from both sides of the equation. And what does that leave us with? B squared equals C squared minus A squared. Why did we take away A squared? Because it was a positive A squared, and we need to do the opposite. You know the opposite of addition is subtraction. We know that whatever we do to one side, we have to do to the other side. So, simple enough. Now we've rearranged our equation, time to put the numbers in. We know that A is 9, B is what we're looking for, and C is 10. We've got our rearranged equation here with B squared as the subject. So, let's put them in. B squared equals C squared, that's 10 squared, minus A squared, which is 9 squared. Put that into your calculator, and you get B squared equals 19. Now remember, just like always, we've got B squared here, but we just need B on its own. So what do? Well, we square root it. And what is the square root of 19? Well, round it up, that's 4.36. And that's it. We found a side of our triangle when we knew the longest side and another side. Now, this and the situations we've looked at previously are the only two types of problem you'll see with Pythagoras. Either you'll know the two shortest sides, or you'll know the longest side and one of the other sides. Just to test your skills, let's do one last question, just like the example I just showed you. So we've got our right angle triangle here. We know one of the sides, 11, we know the other side, 7, and I need you to find this side here. Pause the video, have a go, and I'll explain how to do it. Okay, I'm going to assume you gave that a try. Let's get started. So, first of all, we need to label our sides. Which side is which? We know that the longest side, the side opposite the right angle, is always C. The other two sides are A and B. Don't get too stressed about which side is which, it doesn't matter. Okay, now, what do we need to do next? Well, we know that A squared plus B squared is C squared, but we are looking for A, so we want to make A on its own. How do we do that? Well, we take away B squared from both sides of the equation. Because it's A squared plus B squared, we need to do the opposite of addition, and that is subtraction. We do it to both sides, because you can't just do something to one side or the equation will no longer be equal. Okay, so A squared equals C squared minus B squared. Let's just put our numbers out. So A is the side we want to find, B is equal to 7, and C is equal to 11. Working it out like this just makes it really clear what is what. Put these numbers into our new equation now. A squared is equal to C squared, that's 11 squared, minus B squared, that's 7 squared. Put that into your calculator, and you'll see that A squared equals 72. Remember, this is A squared, and not just A. How do we undo the square? Well, we square root. So A, rounding it up, is the square root of 72, which is 8.49. And that's it. That is how you use Pythagoras' theorem to find unknown sides in a right angle triangle. Not too tricky, right?